a semi-batch process. And the type of system we're going to see, system, remember, we already saw it. Open system is there is inlet, something enters, there is an outlet, something goes out, and of materials I'm talking about, to this system. So we have inlet and outlet. Closed system, as the name says, it's closed, no inlet, nothing enters, and no outlet, nothing goes out. So it will be like this, materials. And the isolated system is no inlet, okay, no inlet, no outlet of materials, but we need to include also that there's no inlet or outlet to the system. So here we can actually interact with heat, and here we cannot interact with heat. So this is like the most perfect case, which actually does not exist, but we can approximate many systems to this. Actually, I have in the next slide, I have these examples here. Open system will be this. The bubbles go out, dust can come in here, and what else? I don't know, maybe even a bug, etc. Water can also evaporate, so there's inlet and outlet. It's an open system. A closed system, by the other hand, nothing can go in and nothing can go out. But you know that if you let this in your, I don't know, office, it's, I don't know, it's 5 Celsius degrees, super cold, you like it that way. And then, you know, we are 30 degrees ambient temperature, so the weather will eventually go up and this bottle will be the same temperature as the air. There's heat exchange, okay? And finally, the isolated, which that's why I'm telling you that technically it does not exist. It will be this one here. You have no inlet, you have no outlet. Besides, there's like, because this material is so like it does not change energy. It's like a super bad conductor. You can suppose, like, I don't know, maybe the first 15 minutes the water will be like those 5 degrees, whereas here it will be, I don't know, it's already 10 degrees in 5 minutes. If you let 5 minutes, it increases here, but 5 minutes here it does not actually move. So you can say that in 15 minutes you can treat this system as isolated. So just keep in mind these ones, guys. Open is the most common, enter, out, inlet, outlet. Closed is okay, more typical in thermodynamics. And isolated is ideal, actually it does not exist, but we try to be like that. So don't worry, just reread if you do not understand. The example, I think it's clear. Inlets, outlets, energy involved, etc. And the last thing I'm going to watch, it's this one, the type of systems according to variables. What happens when the pressure is constant? It's isobaric. What happens when the temperature is constant? Is isothermal. What happens when the volume is constant? Isochoric, which is not that common. Like the name, I mean, have you ever heard before isochoric? I didn't hear it before, so I think it's kind of exotic. And adiabatic system, when there is no heat exchange, like an isolation. And that was everything in this section 1 of this chapter, mass balance theory. Please make sure you understood all the material before advancing to the next section. And I'm talking serious, guys, because if you do not understand what's a process, what do I mean with open process, open system, and process variable, etc., you will get lost in the next section. So please, guys, make sure and enjoy your course.